Okay, so in this video I'm going to go over the solutions to the quiz we took at the beginning of the semester. First quiz, in fact. It's based on the kinematic equations and a little bit of understanding of motion. So it'll be useful. This video should be useful for studying for unit tests, the midterm, and even perhaps the finals. So let's get right to it. Number one, we had a fast car rest and travels 700 meters in just 18 seconds. So we have a displacement of 700 meters in a time of 18 seconds. Now that's the information that we're explicitly given in the problem. But there's one more piece of information we need to take into account, and that comes from this little term right there. The idea that it starts from rest tells us that the initial velocity then was 0 meters per second. Okay, so that's our given information. And then our unknown, or what it's asking for, is acceleration. Now, as usual, we have something we're looking for in the things we know, and using that information, we can determine which of the equations we should use. In this case, we should use this particular equation. Okay. And we can solve that for t without too much difficulty. What helps us right off the bat is that because the initial velocity is 0, this term cancels. Okay, it's going to go away entirely. And then if we take this and we solve it, for a, I'm going to get 2d divided by t squared. Plugging in my numbers, divided by 18. Okay, I'm going to pull up my calculator, here. Okay, 2 times 700 divided by 18. Okay. Oops, forgot to square 18 here. Squared calculator. Okay, so here we go. 2 times 700 divided by 18 squared. Okay, and I get an acceleration of 4.32 meters per second squared. Okay. Number 2, we have a baseball thrown upward with an initial velocity of 20 meters per second. The initial is 20 meters per second. How long does it take to reach the peak of its flight where it momentarily stops? So the path this is going to follow is straight up, of course, and then it may not actually move to the side, but just so that I'm not drawing on top of myself, it'll come back down like that. And we know what we learned in class, and from what the problem tells you, frankly, is that there's a spot right at the top of its flight where the velocity is momentarily 0. In other words, it momentarily completely stops. And we can use that to our advantage because it's a point where we have some information that we wouldn't necessarily have otherwise. So now our given values include the initial velocity of positive 20 meters per second. The final velocity, since I'm concerned with where it stops, is 0 meters per second. And of course, since we're in a free fall, the only thing acting on you is gravity. Our acceleration is minus 10 meters per second squared. Okay, and then my unknown, how long? Okay, that's time. Time is my unknown here. Okay. Looking through our equations, we find that the most convenient one to use is this one here. All right, and solving that for time, we get v minus v naught divided by a. Okay, plugging in my numbers once again, 0 minus 20 divided by negative 10. I have a time of 2 seconds. Okay, and we also talked in class about how that that number logically makes sense because I start with positive 20 meters per second. And the acceleration, that number tells me that in each second, I got to add a minus 10 to that. Okay, so after adding minus 10 to my initial velocity twice, okay, or in other words, over a time of 2 seconds, I should lose all velocity I have and then start coming back down, and then that's what we see. Okay. Slightly different scenario. Oops, looks like things got moved around on me here. Slightly different scenario. So the baseball is now taken to the edge of the cliff and is thrown downward instead with this speed of 20 meters per second. So now my initial velocity is minus 20 meters per second, and that minus sign is critical. If you don't put that in there, essentially, if you put it in as positive, you're saying it's this situation up here. Okay, but that's not what we have. We have it thrown downward. Okay, and because I said the initial speed up here, okay, I didn't need to include the negative in the question, so I intentionally did that to see if you could figure out that it needed to be negative. Okay, I'm also given that the time is 5.7 seconds, and is usually acceleration during free fall minus 10 meters per second squared. And I want to know the velocity of the ball just before it hits the ground. Okay, so we know the time of free fall is 5.7 seconds. I want to find the final velocity of the ball. And as it turns out, okay, it's the same equation we used in the last problem. Okay, and even easier, in this case, it's already solved for what we want to find. So minus 20 plus negative 10 times 5.7, okay, and I get minus 77 meters per second. Okay, and again, this makes sense. We talked about it in class as well, thinking of how the acceleration is going to change your velocity throughout time, throughout each second. And 77 is a logical conclusion to come to. Okay, a race car travels 300 miles during the course of a 3.5-hour race. It's got cut off a little, but you can read it. What was its average speed in miles per hour, or mph? Okay. Now, let me shift this one too. This was a question that most people did fine with because it was explicitly asking for average speed, and that's what people seem to want to find anyway. So the displacement here, or the distance, is 300 miles. Okay, and the time that took was 3.5 hours. And since I said, okay, go ahead and find it in miles per hour, then there's no unit conversion necessary. We can just go ahead, take our average velocity equation, which is distance over time, okay, or displacement over time, rather. Okay, say 300 miles divided by 3.5 hours, and I get, I believe, 85.7 miles per hour. Okay. Not a lot of people had problems with that that question, so we're gonna go ahead and move on. Okay. So now this is another average velocity question. In this case, we have two runners who are racing around the track. Okay, they start at the same point, say here. Okay. The first runner starts very quickly and then halfway around begins to walk. Okay, slows way down. The second runner keeps up a fairly consistent pace all the way around. Okay, and they end up finishing at the same time. So distance for the blue guy was 400 meters, and of course the distance for the red guy was 400 meters. And since they're tie, okay, well that must mean that time for the red guy is equal to the time for the blue guy. Okay, so they have the exact same distance and the exact same time, and since we calculate average velocity, okay, again, this is saying talk about the average velocity. Since we calculate average velocity with distance and time, if those two things are the same, then the average velocity of the two runners must be the same. Okay? All right. So, now, so a 105 kilogram man jumps from an airplane about 1,500 meters above the ground. Okay, here's my airplane. Except all my arrows got moved. Okay. So this question had quite a bit of actually useless information in it. And that was sort of the trick about it. It told us that the distance here was 1,500 meters, okay, from the plane to the ground drawn down there. And also told me the mass of the skydiver. Okay, but both of those things are useless information because when you then read on, you find that I'm saying he falls for 20 seconds before he pulls the parachute cord. Well, he's going to pull the parachute cord somewhere around here, hopefully. Okay, he's not going to wait until he travels the whole 1,500 meters to do that. Okay, so then we want to know, so what was his velocity before he deployed his chute? So he jumps out of the plane, and the whole time is accelerating, right up to the point where he pulls his chute, and then, okay, we introduce the air resistance of the parachute, and everything changes, and we can no longer solve the problem in any simple way. So this was really about discerning useful information out of a whole bunch of information. So the useful information was time, 20 seconds, okay, acceleration, of course, since he's in free fall, 10 meters per second squared, and initial velocity, which was 0 meters per second. Okay, I didn't tell you he jumped up or down, he simply left the airplane and started his free fall. And then what we want to know is that final velocity. Well, once again, turns out this is a problem for our first kinematic equation, or first equation of motion. And again, it's already solved for what we're looking for. So plugging in our numbers, 0 plus minus 10 times 20 minus 200 meters per second. All right, so hope this helps clear some things up for you throughout the entire quiz. You can play this back, rewind it, fast forward. If there's anything I didn't cover that you want to talk about, you can always send me an email, and I will answer you that way.